Stanford University.
Okay, there are all sorts of interesting diseases out there, and lots of them are quite exotic. You've got elephant man syndrome, and you've got progeria, which is a disease where you basically die of old age when you're about 10 years old, and then you got cannibals eating brains and getting prion diseases, and those are very exciting, and they're great, junior high school papers about disease and such. So there are all sorts of these great made-for-TV movie diseases out there. But when you want to come to, say, basic meat and potatoes of human medical misery, there is nothing out there like depression. Depression is absolutely crippling. Depression is incredibly pervasive and thus important to talk about. I'll make the argument here today, a number of things, but one critical thing being that basically depression is like the worst disease you can get. And I'll make the argument for that in a bit. It is devastating. It is wildly common. Current estimates are 15% of us in this room will have a major depression at some point or other in our lives. So that is not good. What is also clear is it is worldwide. Currently, World Health Organization says depression is the #4 cause of disability on this planet. And by the year 2025, it's going to be #2 after obesity, diabetes-related disorders. So it is bad news, and it is becoming more common. Okay, so what I'm going to talk about today are seemingly two very, very different topics and tie them together at the end. And what the main point is if you live inside only one of those topics, you're not going to understand this disease at all. First topic being, what does biology have to do with depression? Second topic being, what does psychology have to do with it? Okay, so starting off, first giving a sense of symptoms. And right off the bat, we've got a semantic problem, which is we all use the word depression in an everyday sense. You get some bad news about something, you know, to replace the transmission in your car, somebody disappoints you enormously, and you feel bummed, you feel depressed, you were down for a few days. That's not the version of depression I'll be talking about. Next version, you do have some sort of large legitimate loss, setback, whatever, losing a job, unemployment, death of a loved one, and you are extremely impaired by a sense of malaise for weeks afterward. And then you come out the other end. That's sort of what I'll be talking about. But even more so, what I'll focus on is the subset of individuals who, when something like that occurs, falls into this depressive state, and weeks and months later, they still have not come out the other end. Terminology, the everyday depression that we all have now and then, that sort of version. The second one, the something awful happens and you feel terrible for a while and then come out the other end, a reactive depression. The third version, where you are flattened by it for long periods afterward, a major depression. And what you also see with people with major depression after a while is it doesn't take something awful externally to trigger one of those again. Okay, so what are the symptoms about? If I had to define major depression in one sentence, I would say it's a biochemical disorder with a genetic component and early experience influences where somebody can't appreciate sunsets. And that's what this disease is about. And when you think about it, that is a very sad thing. You look at some of our major diseases, somebody with cancer, somebody crippled by heart disease, and you see the most unlikely things out there. You see somebody saying, well, obviously I'm not glad I'm dying of cancer, but without this disease, I never would have realized the importance of friends. I never would have reconciled with my family members. I never would have found my God on a completely weird level. I'm almost glad this has happened to me. Humans have this astonishing capacity to derive pleasure out of the most unlikely domains. What could possibly be worse than a disease whose defining symptom is the inability to feel pleasure? Thus, at the top of the list, anhedonia. Hedonism, the pursuit of pleasure, anhedonia, the inability to feel pleasure, that is what a depression is about. And you get someone who has just had some enormous good luck, a long-sought relationship, works out well, whatever, and they feel nothing. An inability to feel pleasure, way at the top of the list. What else? Grief, guilt, and that's where we've got the semantic problem again. which is the everyday sort of depression. Something happens, bumps us out, and by definition, we are feeling some version of grief. Often we start obsessing at that point over some miserable thing we did to somebody 12 years ago and sort of despair in that. When you're talking about major depression, the grief and the guilt can be so severe that it actually takes on a delusional quality. Okay, not delusional in the sense of a schizophrenic with delusions, hearing voices, thought disorder, but a certain style with extreme depression. Let me give you an example. You have late middle-aged guy, perfectly healthy, and suddenly out of nowhere, he has a major heart attack. He's lying there in the hospital, and the reality is he's going to recover. He's going to have to make some changes in his lifestyle, but he's going to recover. He instead falls into a major depression. This has transformed his sense of who he is. Suddenly he's an old man. Suddenly there's all these things he can't do. He falls into a major depression. Yet he's recovering. Every day his family is in there saying, look, you're just depressed. You're getting stronger. The doctors are saying you're getting stronger. You're just depressed. It happens the hospital is circular. It has a corridor that forms a circle in it. And one day the family is in there saying, you're getting stronger. Look, the nurses said yesterday you did 1 loop around the hospital, and today you did 2 loops. You're getting better. You're getting stronger. And the person says, no, you don't understand. They're doing some construction. Last night, they closed down the outer corridor and they opened up a new little one. So the 2 versions of this one, 2 loops there, shorter than the large one. I'm getting weaker, I'm going to die, I'm hopeless. This is like someone expecting to believe that last night they were like beavers digging through the walls there, making this new. This was the father of an acquaintance of mine, a structural engineer. This is what a structural engineer looks like when they're delusional to the point of saying that this is a world in which everything is inevitably getting worse. Depression built around that. Next, of course, one of the most dramatic and one of the most awful symptoms of depression, self-injury. Depressives mutilating themselves at a high rate, and of course, most notoriously, suicide, risks of suicide, and that is absolutely tragic in teenagers, early adults. That, along with accidents, is the leading cause of death. Major bad news. Another set of symptoms that wind up being informative, something called psychomotor retardation. Everything is exhausting. It's exhausting to do stuff. It's exhausting to think stuff. You were there and, you can't do the laundry because where's the basket? And you got to find change for the machine, and you got to go get detergent, and just, it's too much. Everything is too much, and you fall into this paralyzed state. Something very interesting in that regard. You get someone who is severely depressed, like to the point of hospitalization, and when they are absolutely crippled with psychomotor retardation, that's not when you worry about suicide. This is someone who's having enough trouble getting out of bed and getting dressed each day. They're not going to figure out how to shred the hospital mattress and make a noose out of it. Where you've got your problems is when somebody begins to get better from a severe depression. When they're starting to come out, that's where the psychomotor retardation relieves enough that suddenly they've got the energy to do something catastrophic. That's when people are on suicide watches, when you have clinicians who are oriented well. Next, something really interesting. And in lots of ways, the single point I want to hammer in here over and over and over is something that people with depression constantly battle with. Back to semantics. We all get depressed. Bad stuff happens to us. We all get depressed. We feel lousy. We feel withdrawn. We feel sort of a sense of grief, and we're not taking much pleasure, and we withdraw. And then we get better. We cope. We heal. We deal with things in life. What's the deal with you that you can't do that? And there's this lurking sense, given that all of us have periods of being depressed and come out the other end, when you look at people who instead go down and stay down there to this crippling extent, there's always this little voice between the lines there of, come on, pull yourself together. We all deal with this sort of thing. I will make the argument throughout here that depression is as real of a biological disorder as is juvenile diabetes. And you don't sit down a diabetic and say, oh, come on, what's with this insulin stuff? Stop babying yourself. Come on, pull it together. You will see this is just as much of a biological disorder. Part of what makes that clear are a bunch of symptoms called vegetative symptoms. The bodies of major depressives work differently. First set of symptoms. No surprise, lots of people have trouble sleeping when they're having everyday off-the-rack depression. There's a certain pattern with people with major depression. What would you think? You're depressed, you have trouble falling asleep, toss and turn. That's not what you see with a major depressive. Instead, you wake up early. You wake up 4 in the morning, 5 in the morning, you're exhausted, but you're not going to sleep. Early morning wakening. You wind up in an emergency room somewhere, deeply depressed, and the clinician there better ask you at some point, how's your sleep been? Do you tend to wake up early in the day? Early morning wakening, classic sign. Additional thing, while sleeping, sleep is not this monolithic process. There's all these different stages of sleep, slow wave sleep, deep sleep, REM sleep, all of that. There's a structure, an architecture to how we sleep, sort of 90-minute cycles as you go through the different phases. You look at the brain of somebody with depression while they're sleeping, and these different phases are completely disordered. The whole structure of sleep goes down the tubes. Look at somebody when they're sound asleep and their brain sleeps differently. This is not, oh, come on, stop babying yourself. This screams biology. More versions of it. Most of us, what we do when we're feeling kind of down is we eat more, out of this general belief that when you feel unloved, carbohydrates make you feel better. And bizarrely, there's actually a brain chemistry of it, of carbohydrates decrease stress hormone release. So for most of us, you're feeling bummed out about things, you eat more. That's not what you see in major depression, decreased appetite. Another thing you see is activation of the stress response. A class of stress hormones are highly elevated in people with major depression. You also have overactivation of something that's called the sympathetic nervous system, adrenaline. Overactivity of these components of the stress response, and that's really important. Because you look at someone with a major depression who's just mired in this psychomotor retardation stuff, and there's this temptation to start thinking about them as some sort of like sea sponge, some invertebrate thing where you're just so wiped out, you can't even get out of bed. It is just debilitating in that sense. That's not what's going on during depression. What you have instead is somebody whose body is blasting through their overactivated stress response, this enormous battle, all of it going on internally. And the fact that you see changes like these tell you this is not, oh, just so wiped out you can't even activate. This is someone whose body is having a massive stress response 24/7. There's a huge battle going on, and it is all internally, increased metabolic rate, increased muscle tone, all of this again screaming biology. The final thing that says tons of biology is lots of people with major depression have rhythmic patterns to the depression. You will get somebody where they will fall into a depression, where it will have 2 months of extreme severe symptoms, debilitating, come out the other end, and a year and a half later, the exact same pattern, a year and a half later, exact same thing. You have some people who only get their depressions during the winter, something known as seasonal affective disorders, SADS, and this is someone where something horrible happens to them in June, and they feel sort of sad for a couple of weeks, and they come out the other end, and nothing happens in January, and they fall into a depression, and they're hospitalized for a month and a half, just like every January for the last 10 years. And you see that, and that is all about biological clocks that are out of whack there. It's biology. This is not, oh, come on, pull it together. Okay, so hopefully what that begins to introduce is the notion, amid all these debilitating symptoms, these are ones that are about biology. These are bodies working differently. So starting to focus in more on the biology of it. What's going on in the brain in major depression? What I'll start off with is the chemistry of it. Okay, what we got here, do not panic if you are not sort of familiar with this and have not wanted to think about science since high school sort of thing. You got two brain cells, you got two neurons. The way they talk to each other, they don't actually touch each other. In order for one neuron to send a message to another one, it needs to release a chemical messenger that goes floating over here and does something or other to this neuron. Chemical messenger called a neurotransmitter. And here we have a case of this, and by law, all neurons go from left to right. So this is a cell that continues down this way. It's all excited. It's trying to pass on some news to this neuron. There's a space in between called a synapse. And what this one is doing, because it's all excited, it has these little water balloons filled with neurotransmitters. Excitation signal comes along, dumps the neurotransmitters, they go floating across the synapse, bind to a receptor there, and then suddenly something changes in this neuron. That's how neurons talk to each other. How many different types of neurotransmitters there are? Probably hundreds. And what will be pertinent here is, in depression, there's just a handful of them that seem to be implicated. First neurotransmitter, something called norepinephrine. Norepinephrine first got implicated in depression in the early 50s, in the early 60s rather. What was the evidence? Around that time, the first generation of antidepressant drugs had been developed, something called MAO inhibitors. What do? Okay, so you got your neurotransmitters released because this neuron's excited. What do you have to do? It comes out, it does its thing with the receptors, and then you have to clean up after yourself. You've like dumped all this stuff in the synapse. What do then? You got two options. You can take the neurotransmitter and you can be green in your orientation. You can recycle it. You could take it back up in here and stick it back into one of these. You can do this recycling business. Or you could be terrible and carbon footprint. You can throw out your neurotransmitter. There's like enzymes sitting around here that break it up and flush it down the toilet. What's the toilet? Out into your cerebral spinal fluid, your bloodstream, your urine, whatever. So either recycling or degrade the stuff. So what do these MAO inhibitors do? They inhibit the activity of this enzyme that breaks down norepinephrine. Okay, so what's the logic there? So you inhibit the activity of this enzyme. You don't break down norepinephrine, so it's just floating around there, and for lack of anything else to do, it hits the receptor a second time, and a third time, and a gazillionth time. And suddenly, somebody's depression goes away. What's your theory have to be at that point? Ooh, I bet there wasn't enough norepinephrine coming out. You find a means to increase the signaling, somebody gets better, and you now hypothesize there's a problem with too little norepinephrine. By the late 60s, another class of antidepressants came in called tricyclic antidepressants. What do? Essentially the same exact thing. What they do is they gum up this pump that recycles the stuff. Norepinephrine doesn't get removed from the synapse, has nothing else to do, hits the receptor second, third, 10th time, person feels better. Ooh, I think the problem in my theory is too little norepinephrine coming out. Thus, the norepinephrine hypothesis. More evidence for it, there are classes of drugs that will decrease your norepinephrine release. Why would you want to do that? In some parts of the body, an excess of norepinephrine has something to do with high blood pressure. So you take a class of drugs, something called reserpine, and what it does is it disintegrates these things. And thus, you don't dump as much norepinephrine. Major side effect in lowering somebody's blood pressure that way is they fall into a depression. So you take a depressed person, you find a way of boosting up their norepinephrine signaling, they feel better. You take a normal person, you drive down their norepinephrine signaling, they get depressed, there's got to be a problem here of too little norepinephrine. So that's incredibly convincing. So at this point, what you got to say is, okay, great, that's convincing, that's irrefutable. What does norepinephrine do? And people figured it out in the 50s, and it's got something to do with this. Take a rat and take a certain part of the brain, you put an electrode down in there where you can stimulate the neurons, you can force them to talk to each other when otherwise they have nothing to say, stimulate this pathway, and what you do is you make a rat unbelievably happy. Okay, so of course the question is, how do you tell when a rat's unbelievably happy? And what you do is you make it work in order to get stimulated there. It presses a lever, and it presses a lever 25 times, and it gets a little buzz there, and it does another time, and rats will work themselves to death to get stimulated in this area. It is better than food. It is better than sex. If they're addicted to a drug and going through withdrawal, it is better than the drug. And what you see is this mediates pure pleasure. And this was called the pleasure pathway in the 1950s. So, of course, you look at it, and then what you have to then say is, ooh, do we have the same pathway? Can I get a new one? Can I get a second one? Shortly after that, people went looking and saw the exact same thing in humans. And this would be during neurosurgery, sort of classical neurosurgical techniques. You don't anesthetize the person. The brain doesn't feel pain. Once you've anesthetized the skin and the skull, you get through there, and you can actually keep somebody awake during surgery. And they used to need to do that because you put your little needle down in one part of the brain, and the person flaps their arm, and another part, and they say the Pledge of Allegiance or whatever. And then you look at your little road map, and it says, okay, go 3 neurons and make a left. People had to do that. So it was around the early 60s that people started stimulating the same area in the human brain, and it is unbelievable what you got. There was transcripts of some of these, and you read it, and the person is going on, and they're saying stuff like, oh, that's great, that's great, that's kind of like sex, but you know when you have this itch and finally you get to scratch it, and then, oh, it's like getting back into bed. And you know, remember how like in the fall you'd go out and play in the leaves, and mom would call you in and she made cookies, and then you get into your jammies with the feet on. They just go on like this. It's like, where can you sign up and have this happen? The same exact sort of theme as in a rat. And it was around that time that people discovered that in this pathway it uses norepinephrine. Aha. So if you've got a shortage of norepinephrine in that part of the brain, what have you just explained? That's the loss of pleasure. Great. Utterly convincing. Here's all the reasons why you shouldn't be convinced. Problems began to emerge. First problem was there's something weird with the time course. You throw in any of the drugs I just talked about, and norepinephrine signaling is changing within like an hour. You put a depressed person on those drugs, and they don't get better for a couple of weeks. Something isn't working there. So that was mysterious. Next problem was, it turned out norepinephrine is useful in this pathway. Another neurotransmitter turned out to be even more important, neurotransmitter called dopamine. Dopamine cocaine works on dopamine systems. So suddenly norepinephrine is just a minor player in this pleasure pathway stuff. But the biggest problem came in the late 80s with the introduction of Prozac. Prozac, which is an SSRI, a selective serotonin reuptake inhibitor. What that does is work on a completely different neurotransmitter system, this neurotransmitter called serotonin. What that drug does is it does the same deal. It stops the reuptake, increased serotonin signaling, and then what's your hypothesis? Ooh, you give somebody a Prozac SSRI, they feel better. I bet you there was too little serotonin. So it was during this period where there was just endless tragic, drive-by shootings of norepinephrine people by the serotonin crowd or the other way around. Huge, huge controversy. And of course, like the middle-of-the-road liberals of why can't we all get along would start sort of suggesting that, oh, maybe it's got something to do with norepinephrine and serotonin and dopamine and everybody hold hands and kumbaya and all that. And that's absolutely what's going on. The best evidence at this point, to be insanely simplistic, is that dopamine has something to do with the anhedonia, an absence of dopamine. The absence of norepinephrine has something to do with the psychomotor retardation. The absence of serotonin is this obsessive sense of grief. And interestingly, supporting that notion is you can have an obsessive sense of something else. You can have an obsessive need to keep your utensils perfectly symmetrical and obsessively wash your hands 8 hours a day. Obsessive compulsive disorder, that's helped by SSRIs like Prozac as well. Whatever it is you are just perseverating over like mad, increasing serotonin signaling can help. So you've got at least 3 different neurotransmitters relevant to the pleasure, the psychomotor retardation, all of this, all sorts of other leads floating around in the field. There's a neurotransmitter called substance P. And what substance P is about is pain. Like poke your finger and your spinal cord is neurons there are releasing substance P talking to each other. It's about pain. It's about chronic pain syndromes. It's about whole body burns. Everybody knew this. And then it was discovered that if you get a drug that decreases substance P signaling, sometimes depressives get better. What does that suggest? It is not just a metaphor of depression as psychic pain. Your body is using the same brain chemistry to feel this sort of psychic pain of depression as just telling you, ooh, I just stubbed my toe. Interesting similarities there. Okay, so we got something about the neurochemistry. How about the neuroanatomy, the structure of the brain? And what you've got here is, this is the human brain. This is exactly what it looks like. It comes in 3 colors. And this was this formulation that came out during the 40s called the triune brain concept, which winds up being really, really explanatory. Down here at the bottom, you got the really boring nuts and bolts part of the brain. And as was termed, this is the reptilian part of the brain. Take a lizard, and it's basically the exact same stuff down there. What does this part of the brain do? Like regulatory, boring things. It measures your blood glucose levels, or if your blood pressure is dropped, it sends out a signal to tighten up your blood vessels. Just total boring plumbing type issues. Sitting on top of it is a much more interesting brain region called the limbic system. Limbic system is about emotion. You don't see a big limbic system until you get to mammals. Lizards are not famous for their emotional lives. Limbic system is much more about emotive stuff, fear and lust and anger and rage and poignance and God knows what. What you've got there are all sorts of ways where the limbic system talks to this part of the brain. And what it does is, rather than you being hemorrhaged, ooh, part this brain, your body getting cold, whatever, you're some, elk, and there's some scary other elk there that's got you all upset, and you start secreting stress hormones. That's your limbic system saying, ooh, I don't like the smell of that guy talking down there. All sorts of means by which your emotional part of the brain can talk to stuff down here. Then you got the really interesting area. Up on top, the cortex. Cortex, all sorts of creatures out there have cortexes. We got more than anybody. It is this hugely expanded area. In primates, we proportionally have the biggest one out there. What does cortex do? It makes you do your taxes, and it does like processing visual information and tells you, aha, that's, punk rock, and that's not Beethoven, and all sorts of sensory stuff, associative cortex things. But then there's an interesting part of the cortex that's very relevant to all of this. Okay, suppose you finish the lecture, you go outside, unexpectedly you are gored by an elephant. What are you going to do? You are going to activate your stress response. You may feel a sense of grief at that point. You may kind of hunker down at that point with a little psychomotor retardation. Appetite, there goes the dinner arrangements, sex may not be the most appealing thing under that context. You are having a stress response in response to the sort of insult that this part of the brain is thinking about. So what's a depression? You sit there and you think about kids in refugee camps, you think about the inevitable mortality of your loved ones, you think about whatever, and suddenly your body does the exact same thing as if you were gored by an elephant. And what's going on there is you get the feelings, the abstract sort of depressive stuff there, and this part of the brain is able to make the rest of the brain go along with it as if this was an elephant goring you. On a certain totally simplistic level, what depression is about is the cortex whispering in the ear of the rest of the brain saying, this is as real as you were just physically assaulted by some sort of predator, whatever, and you turn on the exact same thing. On a very simplistic level, what a depression is the cortex having too many sad thoughts and getting the rest of the brain to go along with it. Okay, so if that's how you think about depression, which is insanely simplistic, you can come up with an insanely simplistic treatment for depression, which is get yourself a pair of scissors and just kind of cut through there and separate that part of the brain for the rest of it, and you're home free. That's your, oh yeah, right. Well, that's certainly an advance in medicine. That is a medical procedure. It is called a cingulotomy. The part of the cortex is called the anterior cingulate, a cingulotomy or a cingulum bundle cut. And what you do is you sever this pathway, and people get less depressed at that point. Okay, when does this happen? This is someone where every type of medication and every type of therapy and electroshock interventions and all of that has been tried, and every combination, and they're still on the back ward of the state hospital slashing their wrists every 3 months. That's when people try this. And the amazing thing of this desperate measure is people get less depressed at this point. Okay, so at that point you may want to look at that and say, well, anything else about these people when you've gone through there and just snipped away? Mind you, this is not a frontal lobotomy. Frontal lobotomy is doing something very undefined up there, but instead you're disconnecting here. What else is up with somebody when you've just disconnected part of their cortex from the rest of the brain? Ooh, insofar as the cortex can come up with abstractly sad thoughts and get the rest of the brain to go along with it, maybe the cortex also comes up with abstractly pleasurable thoughts and gets the rest of the brain. Have you just wiped out somebody's ability to have abstract pleasure? Absolutely. So suddenly you are off and running with a great philosophy term paper. Ooh, it's important that we have pain in order to have pleasure and all. This is nonsense. You get someone who's a candidate for this procedure back in the state hospital there with a wrist scarred over, and this is not somebody feeling a whole lot of abstract pleasure anyway. So what does this tell us? You come up with some ridiculously simplistic explanation that, ooh, you make it impossible for this sad part of the brain to whisper sad thoughts to the rest of the brain. The best people in the field thinking about this can't come up with anything a lot more sophisticated than that. So that tells you something about the brain structure with depression. Final bit of biology here, hormones. What do hormones have to do with it? One very important domain of hormones. You take somebody and they're having problems with a class of hormones, thyroid hormones. What thyroid hormones are about is maintaining your metabolism, keeping your body warm enough, all that sort of stuff. If you have a severe shortage of thyroid hormone, lots of things happen, including you fall into a major depression. Hypothyroidism is associated with major depression. There's an autoimmune disease called Hashimoto's disease, which involves problems with secreting thyroid hormone, and that's a basic feature of it. And somebody comes in and you diagnose it and you give them normal levels of thyroid hormone and away goes their depression. Lots of lessons with that. First one is, best estimates are about 20% of major depressions are undiagnosed hypothyroid syndromes instead. The next one it demonstrates is you better, when somebody is thinking about your psychiatric state, you better have somebody there who's thinking about your nutrition, your hormone levels, your nothing about what's going on here is independent of the rest of the body. So a big role for thyroid hormones. Next domain of hormones being relevant. You take women. You take women and they have a higher incidence of major depression than men do, approximately twice the rate. In addition, women have their highest vulnerability to depression at certain points in their reproductive life histories. After you've given birth, a post-parturition depression, around the time of your period, around the time of menopause, all of these scream biology. So you look at why women have elevated rates of depression, and there's biology, there's all sorts of other schools of thought that have gone into it. There are ones having more kind of sociological framework. Lack of control can cause depression in society after society. Women traditionally have less control. No wonder they fall into more depression. There's another school that focuses on a certain style of emotional differences you see between the genders. On the average, women tend to ruminate more on emotionally upsetting things, to focus in on them more. And this sounds totally stereotypical, and when you do the studies, there's overlaps between individuals, but nonetheless, on the average, what you see is these sorts of studies where you get someone after they've just had a fight with a close friend, and what do women do when they give a choice of a whole bunch of activities? They choose to fill out questionnaires about how they met their friend and what the nature of the relationship is, and does the friend have a good marriage, and all of that. You do it to guys, and they fill out questionnaires about, like, trivia questions about the Civil War. Oh my God, they can't express their emotions. No wonder they're impossible. And of course, again, individual variation. This is highly stereotyping. On the average, though, women ruminate more on upsetting emotions than men do. So that is solid science. What is completely unsolid science is the speculation at that point that if you ruminate on bad feelings, you're more prone to a depression. So that's a whole emotional regulation argument. But you come back to that business of women are most at risk for a depression in the 2 weeks after giving birth, around the period of their periods, menopause, and that's all about hormones. And by now, there's a huge literature having to do with the effects on all that stuff over there of estrogen. And progesterone, and probably most importantly, the ratio of estrogen to progesterone, and what's going on around giving birth, one's period, levels of this stuff is just shooting around all over the place, and the sense is something goes out of whack with the ratios there, and everything about estrogen, progesterone, and the ratio can change the number of receptors for these neurotransmitters, the extent to which you do this reuptake pump. Whatever depression is going to turn out to be on this nuts and bolts level, estrogen and progesterone can do something to it. Final class of hormones that are relevant, a class of hormones released during stress. Okay, what's the most famous stress hormone on earth? Adrenaline. Adrenaline is this vastly overrated hormone that I despise because there's a much more important stress hormone out there to which I've devoted the last 30 years of my life. Class of stress hormones called glucocorticoids. They come out of your adrenal gland during stress. The human version is hydrocortisone, also known as cortisol. All sorts of other species out there, you secrete these glucocorticoids when you are stressed. You look at people with major depression, and about half of them have elevated levels of glucocorticoids through the roof. There is something out of whack with the regulation of this stress hormone during depression. What's that about? That's back to people with depression are not invertebrates sitting there in their beds. These are bodies undergoing massive stress responses. There's a huge emotional battle going on, all of it inside their heads. So elevated stress hormone levels. What's very clear is you get exposed to a lot of glucocorticoids and you're more at risk now for a depression. You can see this epidemiologically. You get people, and statistically, before their first major depressive episode, something awful, stressful occurs. And that's where this happens, and this is the subset of people who stay down there far longer. Have one of those first depressive episodes due to some stressful event, you come out the other side eventually, you are no more at risk for depression than anybody else. Along comes a second major stressor, and you fall into a depression, come out the other end, no more at risk for than anyone else for depression. Somewhere around the fourth or fifth stress-induced depression, something happens and things start cycling on their own there, and you no longer need a major stressor to cause you to get depressed like that. That's when the clocks are off and running. That's the transition. Okay, so major stress can predispose you towards depression. More evidence. There's a disease called Cushing's disease where people secrete boatloads of this glucocorticoid stuff. People with Cushing's fall into depressions. There's a whole bunch of diseases where people have to be treated with lots of glucocorticoids. They fall into depression. What are glucocorticoids doing? A whole lot of them, and your brain gets depleted of dopamine. And you're right back in this domain. That's probably the neurochemistry of how you get there. Okay, so what do we got at this point? We got something about brain chemistry and depression. We got something about the structure of the brain. We got something about hormones. You are a card-carrying biological psychiatrist, and that's all you need to know about the subject. And if that's all you know about the subject, you are going to be pitifully bad at making anybody get better. Because all of this knowledge winds up being effective for treating maybe 30–40% of depressives. Vast majority of people, the antidepressant drugs don't do a whole lot there. All you got there is modern cutting-edge biology stuff, and that's not enough. So what I'll transition to here is now talking about the psychology of depression, because you better have that piece in the story or else you're absolutely useless. Starting off with, I make apologies here, but I actually have to say the name of Sigmund Freud here, because he winds up being very relevant to depression. Freud, back when, dealt with this puzzle of the difference between we all get depressed and come out the other end, and the subset of people who crash. The turn of the century Viennese term for people who come out the other side, mourning. You mourn something and you recover. Turn of the century Viennese term for major depression, melancholia. And Freud in this famous essay said, why is it that a subset of us fall into it and don't? What's the difference between mourning and melancholia? And he came up with a really interesting model. Okay, according to Freud, you have mixed feelings, ambivalencies about everybody you love out there. You love them and you hate them and you resent them and you yearn for them and you reject them and all that Freudian stuff. So in this Freudian view, you have lost a loved one. That can also be a loved concept, a loved goal, a loved... You have lost a loved one. What happens then is, in most people, you are able to focus on the love and the sense of loss. You mourn, and you come out the other end. In Freud's view, what melancholia is about is the subset of people who can't put the negative feelings in the background, and instead you are awash in the love and the hate and the regret and the pain and the delight and all of that. And what a depression is this wallowing, this melancholic loss in the ambivalencies you have about the lost loved one. It explains tons. No wonder you have the grief. Lose somebody and go through the mourning business and only one thing is wrong: you've lost this loved one. Lose somebody with melancholia and two things have happened: you've lost the loved one and you have now lost the opportunity to ever make things better with them. No wonder you have the guilt. You're sitting there saying, thank God I'm finally done with this person. They are never going to control my life. How can I think such a thing like that? Sudden crippling guilt, all sorts of other symptoms. And out of this came this wonderful soundbite: depression is aggression turned inward. Because you've got nobody else out there to have these arguments with. This is the person who you have most loved but most hated, and you've never said the things you've needed to hear, and pounding at the door to get them to finally be able to tell them, and now you've lost that opportunity forever, and all you can do is internalize all of that aggression turned inward. No wonder you're not feeling a whole lot of pleasure. No wonder you're secreting stress hormones. No wonder you're not getting out of bed all that readily with the psychomotor retardation stuff. This really powerful soundbite of aggression turned inward. That's great. What isn't great is how in hell do you turn like Freudian ambivalent feelings into something about neurochemistry, or like what do estrogen progesterone ratios have to do with like love-hate ratios? It's great, it feels very intuitive. You can't do modern science on it, which is the problem with the best parts of Freud. Okay, so instead you need to shift over to looking at experimental psychology and understanding what is the psychology of stress. What is it that makes psychological stressors stressful? And an enormous literature now shows that for the same external misery, you feel more stressed, you turn on a stress response, you are more at risk for stress-related disease if you don't have outlets for the frustration caused by the stressor, if you feel like you have no control over what's happening, you have no predictability as to when it's occurring, and you don't have anybody's shoulder to cry on. This is what psychological stress is about. And what a depression is pathological extremes of this. You fall into the cognitive psychology soundbite of what a depression is. It's learned helplessness. It is learning to be helpless. Something bad happens to you, a rat, getting some shocks now and then, you, a human, experiencing some loss, and the logical thing you should do is learn, this is awful. When I'm in this situation, there's not a damn thing I can do about it. It's awful, I feel terrible, but this is not the whole world. And what a major depression is about is you sit there and you're that rat, and in this setting, you get uncontrollable shocks, but put you in another setting, and just by hitting a lever a couple of times, you avoid the shocks. You don't bother doing it because you've learned to be helpless. Just like a human depression. What learned helplessness is taking a circumstance where by any logic, again, you should be saying, this is awful, but is not the whole world, and do this cognitive distortion and decide this is indeed the entire world. And I have no control, I am always helpless, I am always hopeless. This is the psychology of what a depression is about. At that point, you don't have a whole lot of trouble seeing how you wind up in here, stress, effects on some of the dopamine, all that sort of stuff. Okay, so we've got two extremely different viewpoints here as to what depression is about. Modern biological stuff and this totally different world of psychology, loss, lack of control. One version of it, one of the most reliable findings in the whole epidemiology of depression is lose a parent to death when you were under 10 years of age, and for the rest of your life you were more at risk for a major depression. This makes perfect sense. What is a lot of what's going on during your first 10 years of life You were learning about cause and effect. You were learning about, you're learning, is this a world out there where I have any sort of efficacy, where I have any sort of control? And you have just learned in the most big time awful way, there are things you can't control and sometimes they are awful. And what have you just learned? There's all sorts of reasons where one can be helpless. And you're that much closer to this edge of this learned helplessness cliff for the rest of your life. Extremely powerful model here of that. So you got all the biology stuff. You've got this weird Freudian aggression turned inward, which just feels right, but you can't do modern science on it. You got this whole world. How do you begin to put this world and that world together? And the critical link turns out to be stress. Stress is the intersection of the two in a very interesting domain. Okay, depression is a genetic disorder. What do I mean by that? Depression has some degree of heritability. Depression tends to run in families. Depression runs more reliably as you look at closer and closer relatives, and you eventually look at identical twins, and if one of them has depression, the other has a 50% chance. Full siblings who are not identical twins, 25% chance, half sibling, about 8%, person off the street, about a 2%, 50% chance when they share the identical genes. What does that do? That tells you this is a disorder that has a genetic component. What does that also tell you? If you've got 50% likelihood, if you've got all the genes in common, and you've got a 50% chance of not getting the depression, it tells you genes are important, but they're not more important than any other component. So genes in depression are not about inevitability, they're about vulnerability. So what is the vulnerability about? A few years ago, people discovered a particular gene that's really relevant to whether or not you get depression. What was exciting about that? It was a very clear finding. It has since been replicated. What else was exciting about it? It made sense. This was not some weirdo gene having something to do with how your big toe functions. This was a gene having something to do with serotonin. And this was a gene relevant to this whole reuptake, pumping business, all of that. The main point of it is this gene comes in two different flavors. Each one of us has one of the two versions. And you immediately get this prediction, one of the versions, by all logic, should be predisposing to depression. One of them is the one that should get you in more trouble here. So what does it look like when you go and study it? First paper that reported this a few years ago, and this I suspect is going to wind up being viewed as the most important paper in biological psychiatry for a quarter of a century. This was this massive study where a bunch of researchers looked at 17,000 kids growing up in New Zealand, following them year after year and looking at the genetic makeup of these individuals, and then asking in their early 20s, who's got problems with major depression? And then asking this critical question, what does it have to do with this gene? Does the version of that gene that gets you into trouble, by all logic, is that going to set you up for more of a depression? Are you more at risk for depression if you've got the bad version of the gene? And back comes the finding, which is no, it doesn't increase your risk. You look here, and what's your likelihood of depression? And you got the good version, and it's this likely, and you got the bad version, and it's this likely. Doesn't make a difference unless something else is going on, unless you have a history of exposure to major stressors. And what you were able to do is quantify how many major stressors somebody has had during their childhood, their development, and that involves parental divorce and physical abuse and death of family member, all that sort of thing. And what you see is in the folks who have the good version of the gene, as you have more and more of a history of major stressors, your risk of depression goes up, absolutely. Now you look at the people with the bad version of the gene, and as you have more and more of a history of stress, your risk of depression does this. And when you look at the major history of stressors, a 30-fold difference in the likelihood. This is not about, ooh, genes control our brains and genes control our behavior. This is a gene that is relevant to how readily we pick ourselves up after life has dumped us on our rear ends, how readily we recover from stressors. What's the final piece of that story? Glucocorticoids regulate the function of this gene. All the pieces fall into place there. Wonderfully logical, and suddenly you have a way of taking this whole world of psychological components of stress and tying it into all that biochemistry, wonderfully integrated model. Okay, so in lots of ways, this is where the field is at this point. And what should mostly have come through here amid all this minutia and factoids and all of that is the role of stress and the intersection of the biology and the psychological stuff and childhood as a very important time to imprint how vulnerable you are to depression for the rest of your life. But again, the single thing I want to emphasize over and over, implicit in everything on that left side of the board there, which is this is not, oh, pull yourself together, we all get depressed. This is as real of a biological disorder as is diabetes. And that's the thing I most want you guys to take off from here. And in the context of a university setting is rife with major depression, a community of high-achieving type A individuals is rife with major depression. It is all around us, and amid it being all around us, there is this weird, corrosive inhibition, embarrassment, discomfort we have with the world of psychiatric diseases. One of the greatest things, if you're a researcher with disease, one of the things you pray for is for some powerful senator to have their loved one come down with your disease, because they're going to set up a foundation and get special funding, and there's advocacy groups and all of that, not for a psychiatric disorder. That's the one where people don't talk about it. And amid this screaming biology, and this is a devastating disease and all of that, in any place, and especially in a community like this, where everyone is supposed to be golden and functioning and flawless and just gliding through life, this is one of the hardest diseases for people to admit to. So it is there, it's all over the place, and it's biology. And you should be no more inhibited about admitting that you got something going on that's funny with this type of gene than you would be to admit that your pancreas isn't secreting insulin. So let me stop at this point. And again, unfortunately, I got to sprint out the door. Otherwise, I would take questions. But thanks.
For more, please visit us at stanford.edu.